Good day people, this is your boy Eduardo Agbo and welcome to Design Genius. On today's tutorial we are going to show you guys how we're going to use Solidworks floor simulation to come out with analysis on a Lamborghini car. That is, by doing so we are going to set goals, that is, come out with certain parameters that we want to get the results at the end. For example, observe here at the level of the shear stress, you could see here in Pascal, you could choose other parameters like velocity, you can choose other parameters like total pressure, so you can choose parameters like fluid thermal conductivity, and at the end get the result. So here I've decided to choose just the shear stress in Pascal. Here you can see the speed and how the speed varies alongside when we carry out our analysis. So if you're new to Design Genius and you have not subscribed to your channel, please kindly do subscribe, and please, if you have problems when carrying out analysis or any of our tutorial, please kindly leave a comment below. And to follow us, go to Facebook and just type Design Genius, and you're going to meet Design Genius, and you're going to see study materials that are available for you to study designing and increase your level of designing. So without much ado, we are going to start right away. So once flow simulation is activated in there, all what we need to do next is just go to flow simulations and launch the wizard to start our analysis. Here you enter the name of the project, so I'm just going to allow it to be project, for example, okay, and we're just going to move next. So here, if you want to see what we're doing clearly, here we have the project name, the unit system, analysis type, fluid, wall conditions, initial, and we're done. So here you have the parameters here. So it is meters, kilograms, and seconds. If you wish, you could change it. This is pressure, which is in Pascal, and here the velocity, you could change it to maybe miles per hour, so it's meters per second. It's okay. So all you need to do is you just need to continue. So you're just going to next. Now here at this level, I'm just going to take external analysis. We're going to take external analysis out of the car. So we're just going to take exclude cavity, flow conditions, so, and exclude internal space. So once this is done, we're just going to continue. Now if you look here at this level, you're going to notice that there's gravity. So when you check this gravity with respect to the y-axis, that's with respect to our coordinate system, discover that it's minus 9.81. It's okay. So all these values are okay. I'm just going to continue. Now here we're going to carry out analysis. Here what we have is air, so we want the properties of air to be there. So you're just going to choose gases, air, and you're going to hit on add. So this you're going to choose air as a type of gases. So we're going to go next. So if it is humidity, there's humidity in the air and the flow type that you want. So let's just continue next. We're going to take next. Now at this level, this is what we're going to have here. So you just say okay, finish, and you're going to allow it to calculate the volume of the fluid and carry out the necessary parameters that you have to carry, and you're going to continue once this is done. So it's going to carry out fluid recognition of the volume. So you're just going to wait for the analysis to be done, and this depends on the speed of your computer. So once this is done, everybody can see flow simulation icon here. I just come here and click on this flow simulation icon. So if you take a look, you're going to observe that the car is very small with respect to the defined computational domain. So I'm going to right click edit, and I'm going to adjust the computational domain. So once this is selected, I'm going to take this. So for the computational domain, what I'm going to do is I'm going to reduce this. So once this is done, I'm going to reduce this. So someone else can reduce this at this level, and it's almost the same thing. So you're just going to do this for all the three axes. So this is mine with respect to what you have in front of you. You just need to modify the computational domain to have something that is presentable. So to continue, we're going to take the next parameters that we are going to start, which is, so for the fluid subdomain, it's OGA, boundary condition, everything is okay. So we're just going to go to insert goals. So at the level of goals, what we're going to do is we are going to go at the level of let's say we are going to check the forces that are there. So if you look at repair our coordinate system, here we have X and here we have Y. At the level of X, so I'm going to choose X and I'm going to choose y. So if you observe it, you're going to discover that x is what I call my drag force, and y is what I call my lift. So I'm just going to study these two parameters so I could add other parameters at the level of the result when time comes. So when this is done, I'm just going to hit OK. Now once this is done, I'm going to click here and I'm going to call this force. I'm going to change the name of this force here. So I'm going to call it drag. So I'm going to call it drag. So let me just put. So there we have the drag and the lift force. So sorry, drag is D-R-A-G, but for some reasons I can't hit arrow on my keyboard. So that is what we're going to have. Now once this is done, we're going to run out the analysis to observe. So I'm just going to hit run and I'm going to choose run. So now I'm going to wait for this analysis to be done and executed. Now once this is done, I'm going to obtain my results. But don't forget, this all depends on your geometry and the speed of your machine. So let's just wait for it to be done. So we see how the analysis is going on. So you're just going to wait for it to arrive at a certain level. So we see how it progresses, and here you can see the CPU time. So you can see the time that's left for the analysis to complete. So it's okay. You see at this level they say ready and solver finish. So what we're going to do is we're going to close this, and you're going to discover that here we already have the results that have been loaded here. So if you discover that your result have not been loaded, so you just click on right click, or you come here, you choose load, or you come here load. So what I'm going to do is this. So we are going to go at the level of plot surface, right click, we're going to choose add. But permit me, before we do this, what we are going to do is this. I'm going to close this and I'm going to go to the computational zone. So I'm just going to click there, right click on the computational zone, and I'm going to hide this computational zone so that we are not going to see it there, and it's more presentable this way. So I'm going to go to surface plot, I'm going to insert. Now at the level of surface plot, I'm going to insert. Now I'm just going to choose contours. I'm going to choose all the surface, choose contours, and I'm going to choose here, and we're going to see the maximum and minimum pressure that has been given here. So we are going to allow these values as it is by default. So we're going to click this and we're going to allow it to calculate. Like I said, it depends on the speed of your computer, and this result is going to see at the end. We're going to see what we're going to obtain at the end. So while calculating, this is what we obtain at the end, and you can see how some certain surface have been plotted. So here you can have other parameters that are wasn't fixed. You could choose to see them, but we are not true since we want to carry out an animation. So what I'm going to do, I'm going to choose this surface plot. I'm just going to go to hide. So I want to hide the surface plot for the moment. What I'm going to do now is I'm going to go to Solidworks trajectory. So I'm going to click on this, and I'm going to observe here I have 20, so I will take it to 100. So taking it to 100 here where I have pipes. So where I have pipes, I don't want pipes there, I want sphere. So I'm going to take sphere there, and I think everything is okay. Now for this part, I'm going to choose elements that I want to put inside here. So I'm going to choose now the surfaces that are in contact directly with air. I'm going to choose this surface, and once this surface has been chosen, I'm going to choose this surface. Okay, I'm going to choose this surface, and I'm going to choose this internal part. So we are going to do the same for the rest of the geometry. So when everything's okay, we're just going to hit OK, and we're going to wait for the analysis to be true for us to get the same report, just like the case of the surface plot. This process normally takes long, so it depends on your computer capacity, so you just have to be patient with respect to your geometry. Now based on the geometry and based on what I've chosen, this is what I'm going to obtain. So you're going to see how the air is distributed around for the surface. So if my car is the Lamborghini car is to remove, this is how air is going to be around this corner. Now this, what we're seeing here is the pressure. So what I'm going to do is I'm going to bring in I'm going to bring in this show. So what I've done is this. So if you observe, we have brought in the surface plot, but at this level we can change the parameters. So you just come here, instead of pressure, so we could decide to take the velocity following the x-axis and see how it's going to look like. So if I choose this is how it's going to look like. So we see 0 here because we didn't define the speed. So I'm going to go, the speed is following the x-axis. So at the level of the x-axis, I'm going to click here. I'm going to take the speed to be 20 meters per second. So I'm going to apply this. That is done. We're going to go to the level of goal plot, and we're going to insert the goal plot. So for the goal plot, we're going to choose all. So it's going. So at this level, we're going to take the goal plot. We're going to choose all, and we're going to choose export to Excel. So it's going to export, and we're going to obtain the report that we're going to look. So this is office. So you're going to see the drag force here. Normally this arrow here, I was saying, now you're going to look at the drag force and going to look at the lift. So given the fact that we didn't enter the value or determine certain value, so we wouldn't get accurate results. So like I show you, you are the one to define your speed and everything to get your results. So this is okay. So what we are going to do is we are going to go now to flow simulation trajectories. So at a level of flow simulation trajectory, you're going to right click and choose animate. So once we choose animate, so this is what you're going to obtain. You're going to obtain something like this. So when I zoom out, I'm going to see that this is it. So I'm going to go to this level and I'm going to animate this. So you discover that once the car is moving, you're going to see how air around it is going to be moving. It's going to be circulating. So this is what we're going to obtain at the end. You're going to see how air that is found around it is going to be moving with it. So this is an animation, and so please don't forget to subscribe to our channel, and see you on next tutorial. Goodbye.